I realize that there's a little bit more to the story of solar power from orbit. I talked yesterday about how expensive it is to launch a system into orbit. That ultimately is the killer. But there are a lot of sort of secondary arguments, secondary considerations that get talked about. There's a huge, and just about every lecture you'll hear on solar power from orbit is they'll talk about how, you have sunlight in orbit for 24 hours a day. It's brighter than anywhere on the Earth. But you got to keep in mind that the Earth is in space. The Earth is also collecting sunlight. It's not like the Earth is in some shadow and the only way you can get solar power is to go into orbit. What's going on is that, you can collect more. You can collect more in orbit than you can on the Earth. You can collect maybe 6 times more. You have more hours in the day for collection, and you don't have the atmosphere blocking, you don't have clouds. Okay, I buy all of that, but it only gives you maybe 6 times more power collection per square meter of collector. And what I said yesterday is like, okay, well, just buy 6 square meters of collector for every square meter that you would put into orbit and mount that in Arizona. That extra 5 square meters is going to be a lot less expensive than launching that 1 square meter into orbit. Okay, all of that efficiency, okay, you can argue it, but that's really only part of the equation. The other part is that you have to park this thing at geosynchronous altitudes. And I didn't talk yesterday about why, but for the same reason that communication satellites need to be parked at geosynchronous altitudes. That's the only way you can park the thing over one spot above the Earth. So if you're beaming it back to Earth and you have a wire mesh that's collecting microwaves from orbit, you have to be in geosynchronous altitudes in order to maintain that alignment. Okay, so now you have this target. It's wherever. I mean, you can put it anywhere you want within that can be accessed from geosynchronous altitude. Near the equator would be a little bit better. But nonetheless, you have to have this mesh. Okay, how big does it have to be? Well, from 22,000 miles away, it can't be the size of a house. It can't be the size of a park. It really has to be the size of a county. It has to be really pretty big. Maybe several thousand square kilometers in order to produce a big enough target to shoot at with an antenna from 22,000 miles away. The bigger the grid on the Earth, the smaller the antenna can be on orbit. But nonetheless, in order to concentrate 90% or maybe all of it, you really have to get it all into that area, because you can't have like stray microwaves straying off into subdivisions and lighting up people's light bulbs even though they're not plugged in. Okay, so you're going to have gigantic antennas in orbit. Well, okay, I talk about gigantic antennas, but maybe not gigantic compared to the size of the solar collectors. But nonetheless, by far the largest antennas we've ever built on the Earth or in space will have to be up in space. And they will have to be aimed very precisely, and you're going to have 2 of them, because half the day the Earth is going to be on the sunny side of the solar collector, and half the day it's going to be on the opposite side. The Earth it may be directly below your spacecraft entirely, but your spacecraft has to aim at the sun, and it's from the perspective of the spacecraft, the sun is moving. So half the time, one antenna will point away from the Earth, and the other one will point at the Earth, and so you're going to have 2 gigantic antennas that are very accurate, that steer. They have to steer because the spacecraft the majority of the spacecraft, the solar collectors, have to continue to point at the sun. So you have to have steerable, gigantic antennas that stay on target. Okay, well, so far I haven't said anything that's going to persuade people that this is impossible. All right, let's take it another step. I can do the doomsday scenario where your spacecraft loses control guidance control. It's not unusual that spacecraft lose guidance control and they start to drift a little. And now you have, huge amounts of power, gigawatts of power that are concentrated into a beam that's maybe 10 kilometers wide, 50 kilometers wide. I mean, you're talking the size of Rhode Island at that point. You're going to beam that into some subdivision or some city or just across farmland or whatever. If you lose control, this thing is going to go, crazy. It's going to make a mess. Okay, well, you say, just shut it off. You send up a command, stop beaming power. But the thing is, you really can't. The best you could probably do would be to switch power to the other antenna and beam it off into space or something. If you've got control over the spacecraft. If you don't have control over the spacecraft, it's going to beam the power wherever the hell it wants to. Okay. The other one that I had pointed out to me is that you have considerable losses just translating electrons into microwaves and collecting it with a mesh and translating that back into electrons and getting it into the grid. You're going to lose maybe half of the power just getting it to Earth. And I'm being charitable. It's probably a lot more than that because I really have severe doubts as to whether or not you can beam the power that accurately. Okay. And you have to beam through the atmosphere, and you have to beam through clouds. So you have to pick a frequency that can get through the clouds, and clouds will attenuate. Rain will attenuate. So you can't put your collector in a rainforest. You have to put it in a desert somewhere. Okay, well, you find a desert somewhere. So you lose. So you had like an order of 6. You had 6 times more efficiency by going up into orbit, but now you've lost half of it trying to get that power back. So now you're talking like 3 times more efficient than having it on the ground. Okay, so the other is that there are all kinds of costs associated with running a spacecraft. Maybe that all pales. I keep thinking about how much it costs to put a spacecraft in orbit to produce 10% of the U.S. power consumption that would be the size of a small New England town. The 100,000 launches that would take. Okay, well, that sort of dwarfs any argument I would say about this thing being more expensive. But in every aspect, it would be more expensive. It would be more difficult to maintain a spacecraft in orbit than maintaining an installation in Arizona or New Mexico or Utah or whatever. But okay, then there's other hazards. It's like it's not just you're beaming to a mesh. You're beaming through a column of space. So if an airline flies through that column by accident, what happens? If a hiker wanders onto that area, what happens? Okay, well, you have to have a security system, a really expensive security system to keep people out. What if the International Space Station flies through that beam? What if the GPS satellite flies through that beam? You can't steer everything out of the way constantly. Maybe the ISS you can steer, although that's going to, piss off NASA that they have to steer their spacecraft around all these beams coming from orbit. I assume that there would be more than one of these installations. It'd really be kind of dumb to try to put it all into one spacecraft. Okay, so it's a hazard. It's a really potentially dangerous hazard. It's inefficient in terms of getting the power from space down to the planet. It costs 50 times. I ran the math again. At least 50 times more simply to get it up into orbit than to build the same capacity in Arizona. And I'm thinking, okay, well, just give me the money. I'll build solar collectors, and I'll take, that extra 49, times that huge money that we're spending on launch vehicles, and I'll buy and build a battery storage system. I can build any kind of storage system for the kind of money that you're talking about putting this thing into orbit. So build a bigger system on the Earth, spend a little bit of that launch cost that it would cost you to get it into orbit to store the power overnight so you can use it overnight, because that's the big complaint about solar power is you can't use it at night. All right, well, for the price of putting a system into orbit, I could build, design, whatever, any kind of power system that would store that power overnight. I could overbuild. I could have tremendous amount of capacity and still come out way ahead of anything that you can put into space. So, I don't know. I mean, if you're really convinced that space-based power is the absolute right way to go, and you're just saying, oh, this guy is full of shit, well, okay, that's your position. That's how you think. That's how you go about the world. But if you look at the numbers, if you just look at the numbers, you look at it from just a sensible engineering standpoint, it will cost you a lot less to do it on the Earth. Even if you splurge, it will cost you a lot less to do it on the Earth. And anything that you can do in space, with respect to generating power, is going to cost at least 10 times less to do it on the Earth. And I'm talking 24/7, reliable, doesn't, cook some coyote that wanders off into the grid collection area. So anyhow, just think about it. Just think about it in reality, that you really, if you're convinced that this is the way to go, space-based power, what you really have going on here is you have what we call a solution in search of a problem. This is a solution. It is a potential solution for other things. Potentially if you're colonizing an asteroid or whatever, okay, sure, you need to make power in space. I mean, clearly, if you're running your own, the ISS makes its own power in space and it uses it there. That makes sense. I'm not saying that you don't ever put solar powers into space. I'm just saying the idea of putting a gigantic array that costs, trillions of dollars to put into space in order to make a small percentage of the power that we use on Earth, just doesn't make sense. It's so far out of alignment with reality. So I'm not going to convince you if you're as convinced as some people can get about things. But if you have any doubt at all, run the numbers. Do the math. It's not calculus. It's not hard. It's just multiplying, dollars and cents, doing a little bit of research, and you'll figure it out. You'll figure it out that the idea of beaming power from Earth in any form, from space to Earth in any form, is just not feasible. It does not make sense. So anyhow, sorry for the tirade. I normally would rather be a little bit more positive, but I really can't find anything positive to talk about on this. So anyhow, I would really appreciate your comments. I have a pretty thick skin. I have no vested interest here. I just, part of my job in life is to weed out the bad ideas so better ideas can take root. Let's work towards a better solution. Let's figure out better ways of doing things. Let's not just throw all of our eggs into a basket that says we're going to follow this idea that doesn't work, and we're going to tell everybody that doesn't agree with us that they're morons or something. Well, the smart people are saying no, it doesn't work. It doesn't work. Sorry. Anyhow, have a nice day. I hope I've helped in some fashion. Take care. Bye bye.